Welcome to the video presentation of the visualization and simulation tool created for interactive services within smart homes. The tool is built in the context of the European project Smart Homes for All. The vision of the project is that in the future home appliances will be exposed as services, so people can live in smart homes. Home services can then be orchestrated to increase comfort and safety for the user. With the visualization and simulation tool, we create environments to test web service-based middleware. This is especially useful in the context of pervasive systems, where testing in the physical environment is expensive and time-consuming. The tool is based on Google SketchUp version 7 and Ruby. Invocations to SketchUp are performed via standard web service messages expressed in SOAP. In other words, any object visualized in the home can be seen as a web service that can be evoked remotely. One can use any existing SketchUp model or create a new one to represent a real or imaginary house. Then one decides which objects are exposed as services and what is their behavior. The SketchUp server is coupled with a SOAP server, which acts as a message broker for the visualization. In a typical interaction, a client sends a SOAP message to the server, which dispatches it to the SketchUp application. This generates the response, sends it back to the SOAP server that in turn responds to the client. The client can be any application capable of SOAP. Currently, we support Ruby, Java and the active BPEL engine. Let's begin by showing you how it works with Ruby. The SOAP broker starts and is ready to communicate with both the clients and SketchUp. The broker can support several simulations environments at the same time, and, naturally, multiple clients. The client sends a sequence of commands which are stored on the server. SketchUp is notified and can pick up the messages as it consumes them. Let's now look at an example of commands issued to SketchUp. The home user moves to the TV. The TV is then automatically turned on. On the left side of the home, lamp 1 turns on automatically, then lamp 2. Suddenly, the gas sensor detects a gas leak in the kitchen. This triggers the immediate opening of the windows and also sends a notification about the gas leak to the TV. The kitchen door opens automatically, the TV pauses as the homeowner moves to the stove. The door closes automatically, and lamp 1 and lamp 2 are turned off as they are not needed while the person is in the kitchen. The homeowner shuts off the gas. He then proceeds to the fridge as he wants to drink a beer to cope with the stress. The fridge door opens automatically. He takes a bottle of the beer and closes the fridge. He returns to the living room through the already open kitchen door, which closes automatically, and resumes to watch TV, while the lamp turns on automatically on the left side of the wall. The SOAP broker also gets answers from the SketchUp representing the responses of the virtual home services. Interestingly, the simulation visualization environment can also be coupled with services residing elsewhere. For instance, one can couple the simulation with services residing on the motherboard of a fridge, who can also talk SOAP. When the client issues a request to open the fridge and to consume a beer, the hardware will receive the message and change its state. At the same time, this will also be visible in SketchUp. To conclude, we have presented a visualization and simulation tool for interactive services in smart homes. Thank you for your attention.